So in this question, we need to find out the heat current in this given situation when we have two thin spherical shells of radius R1 and R2. The inner wall is maintained at a temperature of T1 and the outer wall is maintained at a temperature of T2 such that T2 is greater than T1. The region between these two shells is filled with a material of thermal conductivity K. We need to find out the heat current. Now the heat current will be constant throughout. We can say that because let us consider any region. If the heat current entering this region is not equal to the heat current going out of that region, then heat will accumulate in this region, due to which the temperature of this region will increase. But we know that at thermal equilibrium the temperature of all points becomes constant, that is fixed. Therefore there will be a constant heat current. We need to find out that heat current. So we know the formula for heat current to be equal to minus Ka dt upon dx. Now in this diagram A is not same, therefore we have to integrate. Also dt is different, therefore we need to integrate. Let us take a thin spherical shell of thickness, this is a thin spherical shell of thickness dx, this thickness is dx at a distance x from the center. Now let us write the equation for this. Let the temperature on this side be theta and this side be theta plus d theta. Let us write this as T and T plus dt. Since there will be a very small temperature difference across this very small dx element, ds thickness of the uniform thin spherical shell. Therefore, let us write the formula for current. Current will be equal to, let us remove the minus sign because the minus sign tells only the direction. We will take care of the direction. We know the direction is from outside to inside. Let us write this. This is equal to K into the surface area which is perpendicular to the current, that is equal to 4 pi x square into dt, that is a small change in temperature, upon dx, that is the length across which the current travels. Therefore we get this formula. We need to find out this constant heat current. So what we need to do is, we write this as dx upon x square is equal to 4 pi k dt. We integrate x from R1 to R2 and we integrate t from T1 to T2. This is 4 pi into k. This is k here, 4 pi k into integration dt. This comes out to be minus 1 upon x, that is equal to 1 upon R1 minus 1 upon R2 is equal to 4 pi k into T2 minus T1. Now we needed to find out the, sorry I missed out on this term. Here we have an additional term of I into this. Therefore I into this is equal to 4 pi k into T2 minus T1. Therefore I can be written to be 4 pi k into R1 R2 into T2 minus T1 upon R2 minus R1. So final answer for the heat current comes out to be equal to 4 pi k into R1 R2 into T2 minus T1 upon R2 minus R1.